Next, we're going to turn to the page where the objective is to calculate the surface area, lateral area, and volume of cylinders and prisms. So this is something that we've seen part of this before. Area, we've talked about area in the past, and since each of the sides of a polyhedron is a polygon, and since we already know something about how to find the area of polygons, it makes sense that we could find the surface area, because it's just basically the area of all these polygons added together. So the surface area is the area of the faces of a polyhedra, if we're talking about a polyhedron. If not, it's the area that lies on the surface of the solid. So that, for example, if we go back to any of the diagrams we've had in the past, let's take a look at the triangular prism, for example. Let's look at the surface area of this. What exactly are we talking about when we're talking about a surface area of a triangular prism? Well, we're talking about the sum of the areas of all the faces. Okay, so there are 1, 2, 3, 4, 5 faces in a triangular prism. That means that the surface area of a triangular prism is the sum of the two bases. It would be the sum of the area of this base plus this base, and then we add to that the area of this lateral face, and the one in the back that we can't really see entirely because we've got a dotted line. So all 5 faces added together, the area of all those faces, equals the surface area. What about volume? Well, volume is the three-dimensional version of surface area. A unit cube has a volume of 1 cubic unit. So volume is a three-dimensional way of calculating what's essentially inside the solid. Okay, it's actually what's inside the solid. So let's take a look at some examples of these. And if we had to write down the definition of volume, we could call this the amount of space. Okay, the amount of space. As an object occupies. You can also look at it as what it contains inside of it. In other words, the amount of space contained inside an object. So let's go ahead and look at the formulas for these. And the reason that we're putting prisms and cylinders in one category is because the formulas for surface area and volume, which are the two major things we're interested in, are very similar. Also, prisms and cylinders each have 2 bases, so that also makes the formulas kind of similar. So let's talk about the lateral area of these 2 objects. The lateral area, well actually, I'm going to talk about the surface area. The lateral area isn't that important really. The surface area is what's more important because that's the total area. The lateral area is just the area around the lateral sides. But the surface area is all the sides added together. So the surface area therefore includes the bases, whereas the lateral area doesn't. So in both the prism and cylinder there are 2 bases. So we've got to add 2 times the area of the base. Okay, 2 times the area of the base plus the lateral area. Okay, but the lateral area can be broken down into the perimeter of the base times the height. Okay, so we're going to say that the surface area is 2 times the area of the base plus the perimeter of the base times the height. Not much room to squeeze all that in there. But we'll see more specifically below as we go to each of these. We're going to repeat this formula a bunch of times. The volume of a prism in a cylinder is also very similar. It's the area of the base, not 2 times the area of the base, just the area of the base times the height. Okay, very simple formula. The volume is the area of the base times height. The surface area is 2 times the area of the base plus the perimeter of the base times the height. So let's see the example. Let's take this first figure here, which is a triangular prism. Okay, and let's calculate the, well, first let's identify the bases. This is the base there, and of course that's a base over there. The 2 triangles are each a base. That's how the triangular prism got its name. What is the perimeter of a base? Well, each side is 8, and this is an equilateral triangle, so we know that it's 8, 16, 24. So the perimeter of the base is 24. Okay. The height, which is the dimension perpendicular to the base, is 12 centimeters. So let me also put down here the height is 12 centimeters. Remember, the base, if it was standing on the base, which we normally think of the base as being something that it would stand on, that would put the base on the bottom, and that's why this is the height. Okay, so let's just put it back for a moment. And capital B is the area of the base. Well, the base is an equilateral triangle, 8, 8, and 8, and we have a formula for the area of an equilateral triangle. If you remember, that would be s squared times the square root of 3 over 4, where s is equal to one of the sides. That means 8 squared, square root of 3 over 4, or 64, square root of 3 over 4, which can be simplified to 16 square root of 3. Okay, so again, each side of the equilateral triangle is 8. That's 64 square root of 3 over 4, and 64 over 4 is 16. So the area of the base is 16 square root of 3, and the units is going to be squared centimeters. Okay, so area is always in squared centimeters, and this is how we symbolize it by putting a centimeter squared. That's just a shortcut for what we're saying. So all areas are in units squared. You might remember that from stuff you've learned in the past. Lateral area isn't too important to me. We might go over this at some point in the future, but I don't want to sort of belabor it. More important to get right to the surface area formula. The surface area here is 2 times the area of the base plus the perimeter of the base times the height of the prism. So let's go and do this. The 2 times the area of the base. The area we said is 16 square root of 3. So 2 times 16 square root of 3 plus the perimeter we said is 24, and the height we said is 12. Putting it all together, and I don't have my calculator too handy, so I'm going to, oh, I do, yes I do. Let me go ahead and add this up, and you should add it up along with me, just to go through it. So this is 32 square root of 3 plus, and 24 times 12 is 288. So that is the surface area. It's 32 square root of 3 plus 288 square centimeters. Okay. The volume let's go down to the volume now. The volume is the area of the base times the height. So volume is area of the base times the height. We still need the area of the base, which is 16 square root of 3, times the height, which we said was 12. And that gives us, for the volume, get out my calculator again, (192 square root of 3) cubic centimeters. And because it's volume, we have 3 dimensions, so we call it cubic centimeters, and we denote that by centimeters with a little 3 up there. That means cubic centimeters. Okay, good. So that takes care of this first figure. Let's see the second figure. The second figure here is a rectangular prism, and I'm going to do that in the next video.